Assalamualaikum. We proceed with the next topic, which is the special distribution for continuous. Okay, the first one adalah uniform distribution. Okay, as you know, uniform adalah one of the special continuous distribution, and then you have learned before this in diploma. Cuma for now, kita ada tambahan that you need to know how to derive the mean and the variance and also the MGF for uniform distribution ataupun untuk special continuous ni lah. Okay, macam sebelum ni you hafal je kan uniform, PDF untuk uniform, you hafal dia punya mean, you hafal dia punya variance, and you hafal dia punya MGF. But now you need to know how to derive all these things. Okay, so first thing first, you should know what is the situation yang very suitable for uniform distribution. Okay, let's read the first paragraph from your textbook here. Suppose that a bus always arrives, okay, at a particular stop between 8 to 8:10 a.m. Okay, and the probability that the bus will arrive in any given sub-interval of time is proportional only to the length of the sub-interval. That is, the bus is as likely to arrive between 8 to 8:02 minutes as it arrive between 8:06 minutes and 8:08 minutes. Okay, dia punya interval tu sama, dalam masa 2 minit dia sampai kan. Okay, so let Y denote the length of a time of a person must wait for the bus if that person arrive at the bus stop at exactly 8 a.m. Okay, if we carefully measure in minutes how long after 8 a.m. the bus arrived for several morning, we could develop a relative frequency histogram for the data. Sebab dia kata kat sini, every day as likely bus will arrive sama ada dalam masa pukul 8 hingga 8:02 minit, and sama juga kadang-kadang pukul 8:06 minit hingga 8:08 minit. So dia punya interval time tu sama kan. So from the distribution just given, it should be clear that the relative frequency with which we observe a value of Y between 0 and 2 would be approximately the same as the relative frequency which we observe a value between 6 and 8. Okay. So dalam masa 10 minutes tu, between 0 and 2 and 6 and 8, approximately the same. Okay. So it is a reasonable model for a density function is as given in figure 4.9 dalam masa interval in between 10 minutes. Okay, area under curve A1 dan A2 kat sini adalah follows the probability of Y between 0 and 2 equal to probability of Y between 6 and 8. Y ni adalah waiting time for the bus to arrive. So dia sama kan. So because of that lah, this is the situation suitable for uniform PDF. Okay, so this one PDF untuk uniform adalah this one yang you hafal before this kan. Okay, theta 1 and theta 2 here adalah a constant. Okay, and the interval for this PDF adalah theta 1 and theta 2. Ataupun kita boleh tulis as this one kan, from interval theta 1 and theta 2. Kalau sebelum ni ada juga textbook gunakan A dan B kan. Okay, so this is a PDF 1 over theta 2 minus theta 1, which is the intervalnya adalah theta 1 and theta 2. Okay, let's see the example. So the parameter untuk uniform ni adalah its interval lah, theta 1 and theta 2 ataupun A dan B. Okay, example 4.7. Arrival of customer at the checkout counter follow a uniform distribution. Misalnya, it is known that during a given 30 minutes period, one customer arrived at the counter. Okay. So kat sini kita punya variable adalah number of customer arrive at the counter. Okay, and then Y adalah follow the uniform distribution. Intervalnya dia kata during a given 30-minute period. So intervalnya 0 and 30. So theta 1 is 0, theta 2 is 30. First thing first, kena tahu dulu variable, the PDF for that variable. So we can create the function of y, which is 1 over 30 minus 0, the intervalnya from 0 until 30. Okay, so here is 1 over 30 lah. So soalannya, find the probability that the customer arrive during the last 5 minutes. The last 5 minutes. So maksudnya nak cari probability of y between 25 minutes until 30 minutes. Berapa customer arrive at this last 5 minutes. Okay, so in order to find this probability, we need the function first. So now kita dah tahu functionnya adalah 1 over 30 with the interval 0 and 30. Okay, so we can find this probability because of y adalah continuous distribution. So nak cari nilai probability untuk continuous variable, kena integrate. Integrate which function? Integrate uniform function, which is 1 over 30 tadi. Integrate from 25 to 30. Okay, interval kita from 0 to 30. Tapi sekarang dia nak cari the last 5 minutes. So maksudnya nak cari probability 25 to 30. Okay, so valid lah kita gunakan this function sebab ianya dalam interval kita lagi ni. 25 to 30 kan dalam interval 0 to 30. Alright. So bila you integrate, so satu part tak dekat sini, saya buat kat bawah ni. Because of 1 over 30 adalah constant, saya buat keluar. So integrate the constant, so you akan dapat y. Betul tak? Okay, from 25 to 30. So last sekali akan dapatlah this part. So the answer will be 1 over 6. 1 over 6 ni adalah probability the customer will arrive during the last 5 minutes. During the last 5 minutes, 1 over 6. Okay, so maksudnya kat sini, the probability of the arrival occurring in any other 5-minute interval pun sama juga 1 over 6 because of it follows the uniform distribution. Y ni follows the uniform distribution. Okay. So macam itulah nak cari nilai probability for uniform distribution. We need to integrate because of y adalah continuous distribution. Okay. Okay, next let's see how to derive the mean and the variance for uniform. Sebelum ni, ini adalah mean dia kan. You hafalkan sebelum ni, mean untuk uniform adalah A plus B over 2. Ataupun theta 1 plus theta 2 over 2. Then the variance for uniform distribution adalah B minus A square divide 12. Ataupun theta 2 minus theta 1 square over 12. So now kita nak tengok macam mana nak derive this mean. Okay, so kita gunakan mathematical expectation concept. Sebelum ni, nak cari mean. It is the expected of y. So because of y adalah continuous, so we need to do the integration of y multiply fy. Y multiply fy. So fy ni adalah from uniform distribution lah. 1 over theta 2 minus theta 1. So first thing first, kena multiply dulu fy dengan y. And then kena integrate from where to where? Integrate from the interval of the function of y, which is theta 1 and theta 2. Okay, so because of 1 over theta 2 and theta 1 minus theta 1 ni adalah constant, so kita bawa keluar. Then integrate y, akan dapat y square over 2. And then replacekanlah y2 dengan theta 1 and theta 2. Okay, so lastly you will get this. Bila replacekan y2 dengan theta 2 and theta 1, so you akan dapat this part. Last kali you akan dapatlah mean untuk y adalah theta 2 plus theta 1 divide by 2. Okay, So how about the variance? Variance kan, nak cari variance, so kita kena guna formula lah sebenarnya kan. The variance of y is better of y square minus dengan mean square. Betul tak? So mean kita dah tahu dah ni, dah derive tadi. So sekarang ni in order to derive the variance of the uniform, kena cari dulu as better of y square. Gunakan mathematical expectation as usual juga, which is we need to integrate y square dengan fy. Integrate with respect to y from theta 1 to theta 2. So it will be y square multiplied dengan 1 over theta 2 minus theta 1 dy. So I buat keluar 1 over theta 2 minus theta 1 because it is constant. So tinggal yang ni untuk kita integrate. So integrate y power of 2 will be y power of 3 divided by 3. Okay, then replace theta 2 and theta 1 as usual. So you will get theta 2, right? Theta 2 power of 3 minus theta 1 power of 3 divided by 3. So what to do is, okay, this part kita kena factorize kan, sebab kat sini ada theta 2 minus theta 1. Di sini so maybe kita boleh eliminate kan theta 2 minus theta 1. So it will be as factorized, dia akan jadi macam ni, theta 2 square plus theta 1 plus theta 1 theta 2 plus theta 1 square. So divide dengan 3 theta 2 minus theta 1. So we can eliminate that part, theta 2 minus theta 1. So last kali tinggallah this part untuk as better of y square, right? Okay, so we can continue to find the variance of y, which is the as better of y square minus dengan mean square. Mean ni tadi kan theta 1 plus theta 2, sorry, theta 1 plus theta 2 divided by 2, all of things square. Okay, this part is mean square. So kita akan dapat this part lah, divide 3, yeah. Okay, minus dengan theta 1 plus theta 2 square. Saya buat ni terus lah ya. So dia akan jadi theta 1 square plus 2 theta 1 theta 2 plus theta 2 square divide dengan 4. Right, so we multiply all this dengan 4, right? So akan jadi 4 theta 2 square plus 4 theta 1 theta 2 plus 4 theta 1 square, right? Minus dengan this part pula, multiply dengan 3 theta 1 square minus 6 theta 1 theta 2 plus minus juga sebab kat sini minus dengan 3 theta 2 square divide dengan 12. So akan tinggal theta 2 square minus 2 theta 1 theta 2 plus theta 1 square divide dengan 12. So we can factorize this, simplify this as theta 2 minus theta 1 square over 12. So this is the variance, how to declare the variance of uniform distribution. Okay, the last one adalah MGF untuk uniform. Okay, kita gunakan konsep yang sama macam sebelum ni. Okay, notation to MGF, MYT, because the variable is Y. It is vector of ETY, okay, which is, because of Y adalah continuous, so kita kena buat integration, ETY multiply dengan FY, integrate terhadap Y, from where to where, tengok interval untuk Y, theta 1, theta 2. So FY tadi, tulis baliklah 1 over theta 2 minus theta 1 dy. So because of 1 over theta 2 minus theta 1 tu adalah constant, saya bawa keluar. So integrate ETY terhadap Y. So it will be ETY divide dengan T, kan? Sebab kita integrate terhadap Y. Okay, kita replacekan Y dengan theta 1 and theta 2. Will be, I put T here, right? Keluar sebab T dah jadi constant. So dia akan jadi E power of, replacekan theta mak theta 2 dengan Y. Sebab kita integrate terhadap Y tadi. So theta 2T minus dengan E theta 1T. Okay, so kita boleh simplifykan dia jadi T theta 2 minus theta 1 divide dengan T theta 2 minus theta 1. So ini adalah MGF untuk uniform yang you hafal sebelum ni. So this is the way how you derive the MGF for uniform distribution. Okay, so that's all. Okay, so itu sahaja untuk uniform.